In this video, I will explain output offset voltage due to input offset voltage, input bias current, input offset current in both non-inverting amplifier with feedback and the inverting amplifier with feedback. Output offset voltage VOOT, total output offset voltage due to input offset voltage VIO, comma, input bias current IB, and input offset current in both inverting and non-inverting op amp with feedback. First of all, draw the circuit diagram. This one is inverting amplifier, inverting operational op amp, operational amplifier with feedback. This one is the diagram. Minus, plus. Inverting means the voltage source V is applied to inverting terminal of the op amp through resistance R1. This one is V0, feedback resistance RF, and the non-inverting terminal of that op amp is connected to ground. This one is minus VEE. This one is a plus VCC. Some load resistance RF. Inverting op amp with the feedback. Suppose Vin is equal to 0. Vin is equal to 0 means this one is R1. Vin is equal to 0 means connected to ground. This one is V0 RL plus VCC minus VEE. This one is also non-inverting terminal is connected to ground. Some feedback resistance is RF. Even in both the inputs are both input voltages are equal to 0. Some output is produced, that is called as output offset voltage. Next one, inverting amplifier. Inverting amplifier completed. Next one is a non-inverting amplifier. Non-inverting amplifier with feedback. Draw the circuit diagram here. Minus and plus. Apply voltage source Vi to the non-inverting terminal of that op amp. This one is R1. This one is V0, RL minus VEE. Some RF is connected here. This is the non-inverting terminal with feedback. Some RF resistance is connected between input and output. Vin equal to 0. Vin equal to 0. The circuit diagram is reduced to R1 here, V0, RF, RL minus VE. VI is 0. VI is 0. This one, the voltage at the non-inverting terminal is V1. The voltage at the inverting terminal is V2. Input offset voltage is VIO. Input base current is here IB2. This one is IB1. These are the some important representations. IB1, IB2, and IB1. This one is IB1. This one is IB2. In both the cases, Vin is equal to 0. This circuit diagram. This one is V2. This one is V1. VIO. This one is IB2. This one is IB1. Both the cases, either inverting op amp with feedback and non-inverting op amp with feedback, Vin is equal to 0. We need Vin is equal to 0 for the determination of total output voltage, offset voltage due to input bias current, input offset voltage, and input offset current. These two circuit diagrams are same. Now we use that circuit diagram, calculate total output offset voltage. This is the circuit diagram. Minus, plus. Non-inverting terminal is connected to ground. This one is V1. So this one is R1. RF. This one is RL. V0. V1. V2. IB2. IB1. This one is VI0. R1 is connected to ground. Now, have to examine the effect of VIO in amplifiers with feedback. First of all, we will concentrate on VIO. Input offset voltage VIO. Due to that VIO, I have to determine output offset voltage VOO. Due to this input offset voltage, need to examine output offset voltage. We have to examine the effect of VIO in amplifiers with feedback. The non-inverting and inverting amplifiers with feedback shown in above. To determine the effect of VIO in each case, we have to reduce the input voltage V into 0. V into 0, this is the modified configuration. First important point is we have to examine the effect of VIO in amplifiers in the amplifiers with feedback. With feedback. Second point is the non-inverting and inverting amplifiers with feedback shown above. To determine the effect of VIO in each case, we have to reduce the input voltage. VI is equal to 0. Therefore, in both the cases, VI is equal to 0. That this configuration is same when VI is equal to 0. Both non-inverting configuration and inverting configuration with feedback. With the Vin reduced to 0, the circuits of non-inverting and invertings are the same. This is the circuits of non-inverting and invertings are same means this is the inverting of amp. Original circuit Vin is equal to 0. Reduced circuit non-inverting amplifier with feedback circuit Vin is equal to 0. This is the reduced circuit. In both the cases, either inverting and non-inverting amplifier case with feedback case, Vin is equal to 0. Thus, the reduced circuit diagram is the same in both the cases. This is the reduced circuit diagram. First case, case 1. Now we wish to examine output offset voltage in terms of external components R1, RF, and the specified input voltage for a given op amp. Now we wish to express VOO output offset voltage in terms of external components. In terms of external components. R1, comma RF, and the specified input voltage. The specified input voltage for a given op amp. VI is there at the input side, and IB1 is equal to IB2 is equal to 0. Therefore, reduce this diagram to another diagram. This is the configuration minus plus. An inverting terminal is connected to ground. This one is V1. IB1 is equal to 0. This one is V2. VI input offset voltage is present between these two. This one is R1. This one is RF. V0. This one is RL. IB2 is equal to 0. But VI input offset voltage is present. Find out the output offset voltage due to this one. Here apply nodal analysis. Here two currents are there here. This is the current I1. This is the current IF. We know that I1 is equal to bias current IB2. IB2 is equal to IB1 is equal to IP, bias current, plus IF. IB2 is equal to 0. Suppose let it be 0. I1 is equal to IF. I1 is equal to, we know that I1 is equal to 0 minus V2 by R1. IF is equal to V2 minus V00 by RF. We know that output offset voltage is represented by the manufacturers in data sheet, either positive or negative. That is the reason we use V1 minus V2, mod V1 minus V2. V1 is voltage applied to non-inverting terminal, that is plus terminal of that op amp, that is equal V1 is equal to 0 minus V2. Therefore, offset voltage is equal to input offset voltage is equal to is nothing but V2 is nothing but V2. Therefore, from that I1 is equal to IF, I1 is equal to IF. I1 is equal to 0 minus V2 by R1, 0 minus V2 by R1, and IF is equal to V2 minus output offset voltage by RF. In both the cases, V2 is equal to minus VIO, V2 is equal to minus VIO, minus VIO by R1, VIO by RF, minus V naught output offset voltage by RF. Bring this side output offset voltage here. Input offset voltage by RF and bring this side, right hand side, RF plus VI above by R1. VIO into R1 plus RF by RF R1. Here RF is cancelled. Therefore, output offset voltage V naught naught V00 due to input offset voltage Vi0 R1 plus RF by R1. Therefore, Vi0 1 plus RF by R1. In both the cases, non-inverting op-amp amplifier and inverting op-amp amplifier with feedback, the output offset voltage VOO due to input offset voltage VIO is therefore V00 is equal to Vi0 into 1 plus RF by R1. This is the AOO. That is the gain of that amplifier 1 plus RF by RF. When an op amp is used in a closed configuration as either a non-inverting or inverting amplifier, we can compute the maximum possible output offset voltage V00 caused by the input offset voltage Vi0 by given by the equation this one. Therefore, finally V00 is equal to Vi0 into A00. This is the equation 1. When op amp is used in when an op amp operational amplifier is used in a closed configuration, that is feedback configuration as either a non-inverting or inverting amplifier. We can compute the maximum possible output offset voltage, maximum possible output offset voltage V00 caused by the input offset voltage VIO by equation V00 is equal to 1 plus RF by R1 into VI 0. Next, second one is output offset voltage. Output offset voltage. Output offset voltage due to input bias current. Due to input bias current. Input bias current IB is equal to average of two base currents IB1 and IB2 enter into that both the inverting and non-inverting terminal of that op amp. Generally IB bias current IB is equal to IB1 is equal to IB2. Input due to input bias current VA input offset voltage is 0. IB1 and IB2 are present. Second case is output offset voltage is due to input bias current, that is V0 IB. V0 IB. Simplified this circuit diagram in both non-inverting amplifier case and inverting op amp case with feedback. We use the same circuit. This one is connected to ground. This voltage is V1. This one is IB1 bias current here. Under quiescent conditions, Vin is equal to 0. This one is R1. Output offset voltage is due to bias current IB. This one is RF feedback current. This one is IB2, V2. Assumption is input offset voltage VI is 0. This one is a load resistance RL. Again, two currents. This one is I1, IB2, and IF. From this expression, I1 is equal to IB2 plus IF. But here VIO is equal to 0 means V1 is equal to V2. V1 is connected to ground. Therefore, V2 is equal to 0. V2 is equal to 0. First of all, I1 is equal to why V2 is equal to 0? Because V1 is connected to ground. VIO is equal to 0 means V1 is equal to V2. Therefore, V2 also 0. I1 is equal to 0 minus V2 by R1, IB2 bias current. IF is equal to V2 minus V0 IB by RF. Here current I1 is equal to IB2 plus IF. I1 is equal to 0 minus V2 by R1. IB2 is equal to IB bias current. IF is equal to V2 minus V0 IB by RF. Therefore, V2 is equal to 0. 0 by R1 is 0. The IB V2 is equal to 0 minus V0 IB by RF. Therefore, this term is bringing the IB is equal to V0 IB. Therefore, output offset voltage due to input bias current IB is equal to RF into IB. This is the equation number 2. Total output offset voltage is equal to output offset voltage due to VIO input offset voltage plus output offset voltage due to input bias current IB, that is IB. These values are substituted here. V00 value already derived in the first portion. That value is 1 plus RF by R1 into VIO. This one is due to VIO, due to, this one is due to IB, plus output offset voltage due to bias current IB is equal to RF into IB. This is the total output offset voltage.